This is one of the methods of solving problems on integral calculus. The issue we have with integral calculus is just like in differential calculus, you have so many formulas like product rule, quotient rule. Unfortunately, you don't are not blessed so much in integral calculus. So what happens? You will have certain techniques and tricks, and these techniques, the exercises are based upon all these tricks and techniques. But the problem that arises is once you do too many problems, like this exercise will be all by substitution, so your mind gets into a prejudice, you know it's substitution. But what if this problem appears after 4 exercises? Then you forget what to use where. It's just like that English spread, fine dining, you should know which fork to pick up for what. Is it a dessert fork, is it a fruit fork, or is it a dining fork? So these problems will be there. Okay. And in all these methods like integration by parts, integration by partial fraction, substitution, you ultimately have to bring it into your original formulas. There's no other escape. So I say it like this: in integration by substitution, this is your I. Your I must be looking for two set of functions. They may be in multiply, divide, I don't know. There will be two functions. Maybe both the functions are algebraic, both the functions are trigonometric. It will be like the same type of functions will be there, in which there will be a son and dad relationship. Directly, or you might have to tweak something, but you will discover a son and a dad. Such that if you differentiate the dad, then what do you get? You will get the son, right? And the dad will be assumed for something, will be assumed, and after that you will differentiate the dad, you will get the son. So the son, ultimately with this process, it will come into one of your known formula format, right? Let us pick up a very simple example. Like for example, by now you have only the trigonometric integration formulas of those functions which you know how to differentiate. Like say in differentiation of tan x is sec square x. So you know integral sec square x dx is tan x. But if I ask you what is integral tan x, you don't know, because nothing you have read so far whose differentiation is tan x. I will try to see it in an interesting manner. You have not studied anything which if you differentiate becomes tan x. Acha, if I ask you, Zoe, how about sec square x? You say, tan x I have studied. If I differentiate, I get. So you have a formula, integral sec square x dx is equal to tan x, but you don't know anything. So let's take the question of, sir, is it possible that we can integrate tan x dx? Straight away, no formula exists. But this is a general formula which we can use later on. You have to remember these formulas also. Like if I ask you what is integral cot x, you don't know. What is integral cosec x, you don't know. What is integral sec x, you don't know. Sec square x, you know. Sec x, you don't know. But we need these standard formulas will now derive and see. Okay. Can I write this as sin x dx by cos x? Okay. Now try to think this analogy. If I make this as dad, his differentiation, some minus minus we will tweak up. That is not an issue. Minus, multiple, factor, all these we can tweak. Scalars are not an issue. If you differentiate this dad, this son can be born. Do you agree? And then something can happen here. So I say that let cos of x be equal to t. I write it. First you see how I do it, right? Differentiate both sides. First I'll do it in an elongated manner and then I'll do it in a short form. Differentiate both sides. You get negative sin x is equal to dx by dt. Sorry. Is equal to dt by dx. ddx of t. ddx of, okay, if you want the first step, then it is ddx of cos x is equal to ddx of t. I'm differentiating both sides. All right. Now, if I make this as sin x dx, this becomes negative dt. Do you agree or not? Madam, sin x dx is mentioned out here. The son is born, right? But next time when we, this is very elongated way, baby steps. Next time when we do, we just do it like this. Say, just differentiate this. What is this differentiation? Negative sine x. Negative sine x. And straight away write dx is equal to dt. That much. You know, this I have shown you why it comes. Perfecto? Okay. And I further write sine x dx is equal to negative dt. Clear, bacha? I'm not changing the screen. So, say from this step, I can now write my integral as sine x dx. I'm writing as negative dt, and the bottom is t. Right? Tweak it better. Now this becomes negative dt by t. Now this is an identifiable format. Dx by x integral is log x. So it becomes what, beta? Negative log of t, and t will be always in modulus because log is always plus c. Agreed? I can write this as log of t to the power minus 1 plus c. Have you understood this one? Okay. Log of x to the power n is equal to n log x. Possible? Can I now write this as, okay, not here, not here. I would write this as log of 1 upon t plus c. Now you release your t, log 1 upon cos x plus c. So this is log sec x plus c. Did you get the trick? This was a straightaway one, but this will work. Now you try to copy it by understanding it, and then we'll pick up one similar in which you will be primary, I will shadow you. You get those, you know, in some spas and all, recliner chairs are available where they'll trap your body in different mold and they'll pressurize. I feel like there should be some mold like that where you lie down and it is so nice. It locks you on your neck, shoulder, back. Clear? Okay. If we have understood this, then Zoe, let's pick up integral cot x dx, similar method. All right. So integral cot x dx can be written as integral cos x dx divided by sin x. Same funda should work. Now I'll take sin x be equal to t. It's much more easier because you don't have the negative adjustments out here. So this becomes cos x dx is equal to dt. Just differentiate this and put the dx. So your integral becomes what, beta? dt by t, which is equal to log t plus c, and just release it. So log of sin x plus c. And hence on, Zoe, you can use these two as your standard formula. So you can write down beside. Integration will open Pandora's box of formulas. Now a lot of sin c plus sin d, sin 3 theta, all these will also come. So two formulas you learned. Integral tan x is equal to log sec x. Integral cot x is equal to log sin x. Acha. Another, we will see a problem. After that, we will take that as a standard norm. Remember one thing, if I would have given you that, Zoe, you differentiate sine mx, let's use our chain rule. D, this is dog, so dd dog of dog will give you what? cos mx. Agreed? And then ddx of dog m. This comes here. In integration is reverse of differentiation. So in differentiation, if it becomes multiple, there it will come in the denominator. We'll just see that. Okay. So let's take a problem where we are supposed to integrate sine mx dx. Sine mx dx. Okay. Later on, how will you do it? 1 minute. Huh? Sorry. How will you do it later on? Later on, sin x dx integral is what, beta? Negative cos x. Because cos x's differentiation is negative sin x. So it will be negative cos mx by m. But let's see this. So let's say we take, let mx be equal to t. Right? Differentiate this. So you get m. If mx is equal to t, then m dx is equal to dt. M dx is equal to dt. Agreed? Now see how we will do here. Now, therefore, dx can be written as dt by m. So your dx you first substitute dt by m. And your sin mx now becomes sine of t. Okay? M is a constant, so I have the freedom to bring it out, and I now write sine of t dt. Isn't it a standard format that you have got? So this is a standard format, sine x dx. So that is negative cos x. This m comes down. Sorry, negative cos t. The m comes down plus c, and now you liberate the t, so it becomes mx by m plus c. Getting a slight grip of it now. You can put this as c1 and keep this as c. C has nothing to do. So you can write c1 by m is equal to c. It's a constant end of the day, right? Chal. I'll write a question now. You need to hunt the son and the dad, okay? Let's see. Bigger a problem, easier the problem. Remember that. Don't go by substitution. You first tell me, are you able to see the son and the dad? Inverse trigonometric functions differentiation. What is ddx of tan x, tan inverse x? Do you see 1 by 1 plus x square? Do you see tan inverse x? So dad and son are present. Sine will become some t. What is the big deal? Okay, so I say now, let tan inverse x be equal to t. This is the father. Then what do I write? Dx by 1 plus x square, 1 plus x square is equal to dt. Tan inverse x equal to t. Tan inverse x's differentiation is what? 1 by 1 plus x square multiplied by dx. So I'm just writing in a little bit advanced method, deliberately confusing you so that you start accepting this norm. Clear? Clear? Yeah, fine. So you have a dx by 1 plus x square. So what is your problem now? You write your sign. This fellow, you have already taken it to be very small t, and dx by 1 plus x square is dt. So easy to get it into your format. It's interesting. So it becomes negative cos t plus c. So negative cos, instead of t, you now resume yours. You said the other day, na, it has started in school, but I still felt that, well, he knows maximum are there with coaching and somebody will be there and all. One thing that India is not good with last 14 years or whatever you say is education sector. We are just, the government needs to take control of education. Then only we can be like Singapore or never. Okay, Bitu, have you understood this type of problem? Okay. So, okay. Let us pick up one more problem, which is like, say, now slowly. See, examples, please understand, examples, all examples need not be easy, because the examples will have easy, medium, hard, very hard, because it is a prelude to the what you call your exercise. So maybe we may not dive into all examples. Don't worry. Sine cube x, cos square x, dx. You see, sine cube x, cos square x, dx. Okay, huge type of a problem. But I know one thing: if sine is dad, then cos is son. If cos is dad, so sine is son. Let us, now here you have to have this. This is a trick. So you can ask me, sir, why did you only do for this? Why not for the other? Well, that will come by practice. Can I write it like this? Guys, are you fine with this format? Okay. This much is okay. 1 minus cos square x. Okay. Actually, according to me, the problem is done now. Just see. Let cos x be equal to t. Negative sin x dx is equal to dt. Right? Therefore, sin x dx is equal to negative dt. Agreed, bacha? So let me put my integral. 1 minus cos square x is 1 minus t square. Right? Multiplied by another t square. And then sin x dx, which is a negative dt. Okay. Okay, let's see this. This is now, if I multiply, if you take this negative, if you multiply t square with 1, it becomes how much? Sorry, t square. Right? But you have a negative, so I have taken this as negative t square. Right? Then t square into t square is how much? Positive t4 minus this. Right? Now can I just put my dt? No one stops me. Then further it becomes integral t4 dt minus t square. So easy, see. Now it has come in our format. So this becomes what? t5 by 5 dt. Sorry. By 5 minus t cube by 3 plus some constant c. Now we can release our t's. So this becomes cos 5x by 5 minus cos 3x by 3 plus. Got it? Perfecto. Let's take one more. Little bit we are getting deeper into the water. Okay. Don't be afraid. Just go by the tide. Okay. Sin x divided by sine of x plus a. X plus a. And obviously I will have a dx out here. Right? Okay. Now, if you take an x plus a equal to t, then what do you get? You get dx is equal to dt. X plus a if you take as t. So let's see. Let x plus a be equal to t. Differentiate this. This would be 1 and this would be 0. So the dx straight away multiplies dx is equal to dt. But sir, what great thing did you do by doing this? Some great thing we have done. Just see. On the top it becomes, so from here what can you write for x? X can be written as t minus a. It becomes sine of t minus a divided by sine t dt. Agreed? Sine a minus b, sine a cos b minus cos a sine b divided by sine t dt. Agreed? Okay, now just see the beauty. If I split them, sine t gone. Okay, so here I'll be left with what, Zoe? Cos a dt. Okay, and here I will be left with cot t sine a dt. Do you agree? Huh? Cos t by cot. This is a constant. This is not a variable. So I can pull it out. Cos a is a constant. That's why we did it. So it becomes cos a integral dt. I think integral dt, you know, it should be t. Okay. And here I write sine a integral cot t dt. This I can write as t cos a. Just see, I wrote it as t cos a. Dt is integral is t cos a. I didn't write the t later because it looks like cos a t, which should not be a wrong impression. Okay. And here what does it become? This integration will be log of sine t sine a. So 1 minute, huh? I should have written this first. Sine a log sine t plus c. Perfect. And now your easy job, man. You just release your x plus a cos a minus sine a log modulus sine argument x plus a plus c. That's it. A job is done. There are some more examples. I'm deliberately not doing it because when we encounter the problem, we will do that. We'll go a little bit into exercises because otherwise there's no point in means pulling you on a tough note straight away. Slight bit of hangover are you getting now? Okay, good. Some spicy Chinese items, if they are served now, like very something spicy means fried rice which has a lot of shredded green chilies and yeah, a little bit of green chilies or something, because you have to have that chill factor. The pain reduces pain, you know that, right? You can't put a head balm on a normal day, but when you have a headache, you can bear that head. That gives you relief. Or it should be something like lots of chili sauce and have some dry chili chicken sort of. Anyways, chalo. Let's look at a problem. Our first problem of the exercise. 2x divided by 1 plus x squared dx. Could you spot the dad? Dad differentiation should be son. 1 plus x square is the dad. If you differentiate 1 plus x square, what will you get? 2x. 2x dx. That thing has to be in your head. You have to target that. So let's do it. Let 1 plus x square. These denominators are going to eat your life. You need to remove, bring everything in one line. 1 plus x square be t, 2x dx dt. So your integral becomes dt by t, which is equal to log of t plus, which is equal to log of 1 plus x squared. So easy, so easy. Let's see the next one. Log x whole square, log x whole square divided by x dx. Acha, now you tell me. Log x. Then 1 by x dx becomes the sun. Very good. So we say let log x be equal to t. Then it becomes dx by x is equal to dt. So your integral becomes t square dt, which is equal to t cube by 3 plus c. Right? And instead of t cube, you're going to say log x whole cube. Yes. Log x whole cube and log of x cube are two different things. Log x whole cube means log x into log x into log x. ठीक है बच्चा? Okay, let's take this. Tell me, how will you do this? So if you take 1 upon x as common, then this becomes a dx and this becomes 1 plus log x. Now I think you know how to do. Let 1 plus log x be equal to t. Sin x, sine of cos x. Next one is also easy. Sin x is easy. Sin x, sine of cos x, right? Have I written it correctly? Yeah, that's very easy. Let cos x be equal to t. Negative. So the integral becomes negative. So you'll have a dt and sin t. Okay. Okay, ddx of cos x is negative sin x. So here we straight away get cos t. If you differentiate this, you should get this. What is the problem, bacha? Sin t dt. Integral sin t dt is minus cos t. Sin x dx is dt. So sin x dx, negative sin x dx is equal to dt. Got it? Ajay, you try to differentiate this. Come on. ddx, how will you differentiate this? This is dog, dd dog. dd dog will give you sine of cos x, right? Then ddx of cos x, another minus sin x, minus plus. 5 minutes rest break. Otherwise, my legs will not give up. Now you give a try to one or two problems. I'm there. I'll also do the next one I want to do for you. That is X. Not that that is tough, just to show you a new technique. So this problem is X into root of how much beta? 1 plus 2x square, right? Or 1 plus x square or 2x square?
1 plus 2.
Oh, okay, 1 plus 2x square dx. Now 2x square will give me a 4x x dx. Basically, I can create a x dx. See, I have a x dx here, Zoe. If I differentiate it, I'll get a 4x dx. These 4s are none of our tension. Scalars can always be tweaked. Okay, so I write find x dx. And this is Pakka. So you get 1 by 4 integral t half dt. So 1 by 4 halves integral will become how much? 3 by 2. 2 by 3 e to the power 3 by 2 plus c. So this is 1 by 6 t. T is 1 plus 2x square to the power 3 by 2.